and it helps me understand like God's creation more and with like the beauty and also like how everything was created so perfect. So first thing I'd like to start off my presentation is by giving a verse. In the beginning, God created the heavens and the earth. The earth was without form and void, and darkness was over the face of the deep, and the Spirit of God was hovering over the face of the waters, and God said, "Let there be light." And there was light, and God saw that the light was good, and God separated the light from the darkness. God called the light day, and the darkness he called night. And there was evening, and there was morning the first day. Genesis 1:1-5. I chose this verse because it kind of like, it's the overarching theme of my presentation, and it just shows like the beauty and how everything was created perfect for God. Before my presentation, I'd like to begin by stating that my presentation arises a lot of thought on the formation of the universe. As a whole, I believe this theology shouldn't separate Christians, and I would like you to keep like your mind open. With that being said, I believe that God used alternative means to create the universe that we know today. So that's my whole start. What sets the Earth apart from other planets in our solar system? So throughout the presentation, I'm going to break it down into these like main points. First, the tilt, the distance from the sun, the liquid on the surface, the resources, the good atmosphere, the spiral galaxy, and the orbit. So first, I'd like to talk about the Earth's tilt. The Earth's tilt is important because it gives us our seasons. If the tilt was off, we'd have a complete imbalance on the Earth. The days would be too long or too short. The seasons would be completely altered. Other planets that have a high tilt experience longer seasons, and their temperature varies a lot more than on the Earth. Mars' tilt varies a lot between seasons, and that causes the temperature to like plummet on one half of the year and then be really hot the other half of the year. So the tilt is very important at keeping like the temperature the same throughout the year. And it helps that it stays 23.5 degrees all year long. So next thing I'd like to talk about is the distance from the sun. This graph, I like this graph because it clearly like displays the true distance between like the planets and stuff. And most graphs today don't really have that, and they have it like all clumped together. And I just feel like this graph like clearly displays the distance, and here are the distances. So if the Earth was positioned farther from the sun, it'd be too cold for life. And if it was positioned closer to the sun, it'd be too warm and it would be really hot on the Earth. So that's why the distance is important. So with resources, currently the Earth is the only planet that has liquid water at its surface. And then without the valuable resources that are on the Earth, that was a direct product of it being formed in one of the densest star clusters, the star nebula. And the rate that the Earth expanded was just like the right expansion rate that we could have we could have a great amount of resources on our planet. So that's why the resources, us being formed in a star nebula, are important. So next I'm going to talk about habitable zones. A habitable zone is basically a distance from the sun, or like a distance that all like water or ultraviolet rays or photosynthesis can be achieved. In every single one of these examples, the Earth is positioned just at the right spot where we could sustain life for each one of these things. So the first habitable zone I'm going to talk about is liquid water. Like I said earlier in the presentation, with the water at the Earth's surface, we're at the right distance where it's in liquid form. Like Mars, which is just right outside the habitable zone, the water is solid and frozen and ice. And if it was positioned closer, it'd be more water vapor, and that's why the atmospheres are really thick in like Mercury and Venus. So that's why the liquid water habitable zone is important. The next habitable zone I'm going to talk about is the ultraviolet habitable zone. And this is basically essential for the synthesis of critical biochemicals. Next habitable zone is the photosynthetic habitable zone, and this is essential in the process that plants convert light to energy. So basically, like photosynthesis and stuff like that. Next is the tropospheric ozone habitable zone, And if the ozone level was too high, it would be too hard for plants to respire, and if it was too low, it'd be hard for animals to breathe. So yeah, that's important. Next is the planet rotational habitable zone, and this goes along with like the Earth's rotation around the sun. If the Earth rotated too fast, it would increase the Earth's temperature, and life wouldn't be the same. That as we know it today, it'd be too hot. And if the planet spin too fast, it would also rotate so fast it would spin outside the habitable zone, where none of these things would be possible. Next is the tidal zone, and this just refers to if the Earth was cleared closer to the sun, it would make it so the Earth only has one face. This is kind of like the moon, and it has one face that always is pulled towards the Earth, that's always light, and it always has one side of the moon that's dark. So if the Earth was created close to the sun, it would only have one face that would experience day, and then one side that would experience night. The next habitable zone I'm going to talk about is the atmospheric electric field, and this refers to the distance between a planet and their host star. If the Earth was closer to the sun, it would build up a lot of atmospheric pressure that would destroy all life on Earth. So in a recent study, astrologists found out that Venus's atmosphere is electrically charged by 60 volts. And if that were to happen on the Earth, and the Earth were to be close to the sun, it wouldn't sustain any life on Earth, and it would just be too much. Next is the atmosphere, and this refers to the solar radiation from the sun. If the Earth was positioned closer or didn't have a good magnetic field around the Earth, the solar radiation would kill life on Earth, and I'll talk about that later in my presentation too. And the last habitable zone is the Milankovitch cycle, and this is due to the sheer size of the moon, it keeps the Earth's tilt consistent. On other planets in the solar system, their tilt varies a lot, and that kind of goes with like back earlier in the presentation, it kind of just changes like the overall temperature on the planet between times of the year. So next thing I'd like to talk about is our atmosphere, and go more into depth with our atmosphere because it's very important to our life on Earth. Our atmosphere shields us from celestial objects and traps essential gases in our planet's atmosphere. One of the vital gases to our existence on the planet is the greenhouse gases that are formed in our atmosphere by mixing water vapor, carbon dioxide, methane, and nitrous oxide, and ozone. In the end, this combination of resources creates and emits like radiant energy, and this is like a greenhouse gas. As a whole, this is essential because the temperature, it keeps the temperature a livable condition at night. One example of the importance of greenhouse gases could come from Mars. On a normal summer day on Mars, it could be 70 degrees, and at night it could drop below negative 100 degrees. So if we didn't have the greenhouse gases in our atmosphere, it would make life like impossible on Earth. So this is a solar flare. Another role the atmosphere plays is protecting us from solar radiation from the sun. Solar flares are intense bursts of radiation coming from the release of magnetic energy. Due to the Earth's strong magnetic field caused by the rotation of the Earth's axis, it creates a strong magnetic field on both sides of the planet. So this is a GIF of the solar flare erupting from the sun. And then this picture up here shows like the poles in the magnetic field, and it actually like blocks out the the solar radiation from both sides, and at the poles where it has the least amount of like protection per se, it kind of like seeps in there, and it causes like the northern lights. That's why we have the northern lights today. Okay, so the last thing I'd like to talk about with this is the spiral galaxy in orbit. So if life can only reside within a spiral galaxy, due to the gravitational pull, it keeps us it keeps the Earth centered at like one spot. Like, I don't know if that makes sense. Like one planet, another planet, it's keeping like the balance. And if like all the planets were clustered, we'd either be pulled to one planet more or another. So this kind of keeps our planet like more on a like track. Okay. So with the Earth's placement, we're almost always able to be positioned between the bands. Astrologers say that if we were to cross a band, it would be disastrous for the Earth, and that's bad. But in our galaxy right now, we're not supposed to cross a band for another 500 billion years, and so our orbit is like perfect. We cross the most minimal, like we have the most like clear orbit from bands and stuff like that. So yeah, so only if we were to cross a band, it would be disastrous for Earth. So here's a video.
People say that human existence is a result of a roll of the cosmic dice. Like the gambler who stakes his life savings on the next throw, we just got lucky in the lottery of life. Some people say there's no purpose in the universe, no grand plan, no God behind it all. Our numbers just came up and here we are. But I don't believe them, and nor should you. If I roll this dice, the chances of getting a 6 is 1 in 6. That's not too bad. But what are the chances of me rolling 6 twice in a row? Well, the odds get longer. It's 1 in 6 times by 1 in 6. That's 1 in 36. So I'd have to be pretty lucky to get 2 6s in a row. Now every time I add the chances of rolling another 6 in a row, the odds go up exponentially and it gets even more unlikely. Now, what if I rolled this dice 70 times and every single time I got a 6? Okay, that's pretty unlikely, but it's possible, right? Well, in fact, the chances of rolling a 6 70 times in a row are around 1 in 10 to the 55. That's a 1 with 55 zeros after it. Now, just to put that in perspective, how long would I have to stand here rolling this dice, allowing about 5 seconds per roll, before hitting that lucky streak and rolling 76s in a row? Well, I had a mathematician friend work it out for me. On average, you would have to continually roll this dice for 100 trillion, 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 trillion years before your numbers come up. That's a long time. What if you applied that thinking to us? What are the odds of us being here? Now, the odds of rolling 76 in a row, 1 in 10 to the 55, as it happens, those are the same odds of something called the expansion rate of the universe being just right for the existence of us here today. From the moment of the Big Bang, when our universe began to rapidly expand, the rate of that expansion was exquisitely finely balanced. Any faster, and the universe would have expanded too rapidly to allow the formation of chemicals, atoms, stars, and galaxies. Any slower, and the universe would have collapsed back in on itself. But as it happens, the universe expanded at just the right rate to allow for life to develop in the future, for us to be here. It hit 70 rolls of the number 6 in a row, first time. And the expansion rate of the universe is just one among 30 or so other incredibly sensitively finely tuned constants and fundamental forces in the universe that must be just the way they are for the universe to be able to produce us. So let's imagine if I went ahead and rolled this dice 70 times, and what do you know, every time it came up 6. No waiting for trillions upon trillions of years, first time. Beginner's luck? Hardly. You would assume that I must have rigged it. Maybe the dice are loaded, maybe there are 6s on every side. It can't be chance. Now let me ask you, why would we assume that this universe with us in it, which is actually way more improbable than my 70 rolls, is just a result of chance? The fact that we're here shows that someone's loaded the dice. In fact, maybe there's no dice at all. What if the evidence points to this life-permitting universe actually being the product of an intelligent mind which intended for us to be here? Now, you could come up with some speculative other theory. Maybe there's an infinite number of universes, giving you an infinite number of chances to roll the dice. Maybe. But we don't have any scientific evidence for it. So if you're hanging your hat on that possibility, then you're every bit as much committed to a faith position as the person who says God was behind it. Believing in God isn't a delusion. It's a perfectly reasonable conclusion when we look at the fingerprints on our universe. And if it's true that we aren't just the fluke result of a cosmic roll of the dice, and that we're actually here because a grand designer intended us from the very beginning, well, that's worth staking something on.
That's fun. Okay. No. That's cool. Okay. So I like that video because it clearly like displays my whole point throughout my presentation is that how could like the universe was created so perfect, yet like how was the universe created so perfect without like God being there? So in every instance so far in this presentation, God's amazing and perfect creation has been displayed. Through the marvelous wonders of the sun to the amazing planet we call home, God's creation has been perfect and seamless. Through studying astronomy in my college class last summer, and the amazing trip my family and I took to Lowell Observatory in Arizona 2 years ago, all the astrologists I met couldn't answer these tough questions on why the universe was created so perfect. In the end, their failure to answer these tough questions cemented my faith in the Lord. Through my upbringing and being taught every day the beauty of God's creation at NMC has established a strong faith that can last a lifetime. Furthermore, it helps me cast the ridiculous ideology the world has created to justify the creation of the universe. In the end, I can say without a doubt that God created the universe. What astonishes me most of all is that the creator of the universe loves and cares for me. So I'd like to end my presentation with this verse because it clearly sums up everything I stated in this presentation. When I look at your heavens, the work of your fingers, the moon and the stars which you have set in place, Psalms 8:3. So thanks for watching. I'd like to give a thank you to Mr. Skinner, who was my advisor for this project.